Hello team, today's challenge is Factorializer Redux. The original Factorializer video I released back in June 10th. And at that time, I used code that looked like this. It used a little bit of recursion. We got it done. We also checked for negatives, checked for being equal to 0 and returning 1. We did all the stuff and it worked great. Some things that I learned since then are the fact that they picked 220 very specifically for the reason that the factorial of 20 is this super huge number here, but it is pretty much as close as we can get to something called max safe integer, right? If we go to factorial 21, we get into exponentials. We get into floating point precision errors, right? And that's really the problem with anything greater than getting the factorial of 20, right? But in trying to review this, I took a stab at it and made a few changes, right? So the factorial, in this case, the call stack will never be exceeded, right? For this recursion. But maybe you don't like recursion. Maybe you're new to it, or maybe you want to try it a different way. And there are ways to do that, okay? So we can grab this, we can bring it down and start to clean some stuff out. Now right here, I'm going to get rid of this and start again, okay? And by starting again, I can do a loop, right? Which is exactly the whole thing. So we're going to let result equal 1. We're just going to start there. It's going to be a let. We're going to change this. And then we can set up that loop. So let I equal 2, doing it right, equal to, and I is less than equal to n and I plus plus, okay? And then we go result times equals the I, right? Whatever I is, just like this. Sorry, result, not return, result. There it is. Just randomly typing stuff. My fingers doing their own thing there. So, but result times equals 1. That's the same as result equals result times I, right? Not 1, but I, okay? And then of course return, this is where we return result, okay? And we can clean that up and do the thing, and it will be ever so slightly faster. Not a lot, right? Because we can only go to 20 in this case, but it might be. And the thing that it does allow for that factorial doesn't, that the original doesn't, is I have no protection in here for going past 20. So if somebody drops a 50 in as the argument, or say a 500 for whatever reason, right? I would start to get really close to the edges of whatever my call stack are, right? I think the max call stack size is like 5,000, but even then, right? With this, I don't have that. I will get floating precision errors because of how the exponentials will work here, right? Again, if we're going bigger, we should probably go with something like big int. But for today, this absolutely does it. And it protects against that max call stack size. So if you don't like recursion, or you're trying to avoid it to avoid that max call stack error, then this also gets the job done, right? But which one did you like? Which one do you prefer? Let me know all that stuff in the comments. Otherwise, for today, this has been Factorializer Redux, and I will see you in the next one.